We usually think about aging as just, well, the number of years we've been alive. But what if the real story, the one that truly matters, isn't about time at all? What if it's about a secret fire that's been burning inside us all along? Today, we're diving into that hidden engine of aging, a process called inflammaging.
Seriously, think about it. What if the number of candles on your birthday cake is kind of missing the point? What if the real thing that determines how we age is happening right now, deep inside our cells, totally unnoticed? I want you to imagine a slow, smoldering fire. You can't see it, you can't really feel it like a normal fire, but it's there, it's always on, just simmering away, and it's subtly reshaping the entire landscape of your body over decades. Now, this sounds like a cool metaphor, but it's actually way closer to the scientific truth than you might think.
So let's get right to it. What is this internal fire? Well, scientists have a name for it. It's a process that's happening in every single one of us, and getting a handle on it is really the first step to understanding what aging even is in the 21st century. The term they came up with is inflammaging. It's pretty straightforward, right? A mashup of inflammation and aging. But here's the key. This is not the kind of inflammation you get when you sprain your ankle. That's a good thing. That's your body healing. No, this is different. This is a quiet, chronic, low-level hum of inflammation that just builds and builds over the years. And this is not just some catchy pop science name. In the actual scientific literature, it's described as a smoldering pro-inflammatory phenotype. Okay, let's break that down real quick. Phenotype is just a fancy word for the traits we can actually see or measure in our bodies. And pro-inflammatory means, well, it promotes inflammation. So what we're talking about is a persistent body-wide state that fuels a slow, burning inflammation as we get older. Okay, so if there's a fire, what's feeding it? What's keeping it going? It's like we're detectives now, and in this next part of the investigation, we're going to look for the culprits, the sources that start this fire and sustain it. And this is the real detective work of biology, isn't it? Scientists have been digging into this exact question for years, trying to pinpoint exactly what's throwing fuel on this fire, day after day, year after year. Turns out they've found a whole lineup of suspects. It's not just one thing, it's more like a perfect storm. You've got the simple accumulation of wear and tear, an immune system that isn't as sharp as it used to be, and then you have these things called senescent cells. I love this. Think of them as zombie cells. They're old cells that refuse to die and just hang around, spewing out inflammatory junk. Add in a faulty cellular cleanup crew, and, yep, you've got the perfect recipe for a chronic fire. Now, out of all those sources, researchers have managed to find something you could call a master switch, a central control point for this whole inflammatory mess. We're about to zero in on a major person of interest, right down at the molecular level. All right, let's meet NF-kappa B. You can just call it NFKB. The easiest way to think about it is as a tiny manager for your body's alarm system. When it gets activated, it screams at your genes to kickstart inflammation. Now, when you're young, this is amazing. It helps you fight off infections. But the problem is, as we age, this little manager gets trigger happy. It starts sounding the alarm all the time, for no good reason, constantly fueling that smoldering fire. And here, my friends, is the smoking gun. This is the moment that made scientists' jaws drop. In one incredible experiment, they took the aged skin from a mouse, where that NFKB pathway was going crazy, and they just turned it off. They blocked it. The result? It was absolutely astonishing. The skin didn't just look younger, its entire genetic signature, which read as old, flipped all the way back to a young profile. This was the proof that NFKB was a massive trigger for the signs of aging. But that discovery, as amazing as it was, raised an even bigger question. Okay, so this switch works locally, in the skin, but is there a central command, something conducting this whole inflammatory orchestra for the entire body? The search for an answer led scientists to a place no one really expected, right into the brain. And here is the big plot twist. It turns out that this exact same inflammatory process, driven by that same NFKB switch, can happen in a tiny, tiny part of your brain called the hypothalamus. And when it does, it acts like a control panel for aging in your entire body. Let that sink in. A little bit of inflammation in the brain can literally set the pace of aging for your skin, your muscles, and even your bones.
So, how on earth does a tiny spark in the brain set the aging clock for the rest of you? Well, it's a cascade, a chain reaction. First, stress and inflammation flip that NFKB master switch in the hypothalamus. That causes the hypothalamus to hit the brakes on producing a really important hormone called GnRH. And then the final domino falls. With less of that hormone circulating, the entire body feels it. Bones get more fragile, skin gets thinner, muscles get weaker. It is a direct line of communication from the brain to the body, telling it to age faster.
But here's where this story takes a really hopeful turn. Because with this discovery, researchers tried something. They treated older mice with that very same hormone, GnRH, to bring its levels back up. And they found it could actually slow down the signs of aging, which is incredible. It suggests this whole process isn't just a one-way street downhill. It might be something we can actually influence. And that brings us to our final stop. If there are molecules that fuel the fire, it only makes sense to ask, are there also molecules that can help fight it? And the answer is a resounding yes. So let's meet the good guys in this story, the molecular firefighters. See, our bodies aren't totally defenseless here. We have our own internal allies. There are molecules like AUF1 that act like a cleanup crew, basically going around and getting rid of the inflammatory signals. But the real heavy hitters, the real heroes, are a family of proteins you may have heard of called sirtuins. SIRT1, 2, and 6 are like a molecular special forces team designed specifically to target and shut down our prime suspect, NFKB. They're the natural counterbalance, constantly working to keep that smoldering fire under control.
So we've gone from a simple metaphor about a fire all the way down to the complex molecular switches inside our own brains that can control the speed of aging. Understanding inflammaging, it just opens up so many incredible possibilities. And it leaves us with one final massive question to think about. If we can really learn to control this internal fire, what could the future of human aging actually look like?